Okay, so what we have is a system of equations, linear equations. We call it a system because we have two linear equations. So the first one is x plus y is equal to 1. The second equation is x minus 2y equals 4. So the first step is to rewrite it in slope-intercept form. Just like what we did last time, where we had a system we had linear equations and we wrote it in terms of a system of linear equations, the general form. Here we take the system of linear equations and rewrite each linear equation in slope-intercept form. So to do that, I'm going to move negative x to the other side. So I have negative x plus 1. So the slope here is negative 1. The y-intercept is positive 1. Likewise, I need to have y on the left-hand side and move everything to the right-hand side. So I would have negative 2y equals minus x plus 4, because I'm moving the x from the left-hand side to the right-hand side. And I need y by itself, so I have to divide by negative 2 on both sides. The negatives will get cancelled, so x over 2, 4 over negative 2 is negative 2. If I rewrote it a bit, I would have 1/2 x minus 2. So we have the slope to be 1/2, and the y-intercept is negative 2. Going to use red for the first equation. So since we have a negative slope, we know the line is going to decrease. And the y-intercept is at 1. So I'm going to put a dot at 1 because that is the y-intercept. If I plug in 1 for x in the first line, so y would be equal to 0, which would mean that okay. So that is the first line. Let me use a different color for the second one, maybe blue or teal. If I plug in, say, 4 for x, then we get 2 minus 2, which will give us 0. So when x is 4, y is 0, the y-intercept of that line ends up being negative 2, which is right over there. So we can connect those two dots. So we can sort of see where the point of intersection is at. The point of intersection, to me, it looks like it's right over here. And it happens to be 2, -1. Now, the graph is quite satisfactory, but you want to verify this at all times by plugging it back in one of the two, both equations. So if I plug in 2, I'm running out of space, I'll write it over here on this side. So if I plug in 2, x plus y would be 2. The corresponding y value and the point of intersection is -1. So -1. And 2 minus 1 is 1, which means the first equation works out with the point of intersection that we have. So the next value of x is 2, because the point of intersection is still 2. And I'm going to plug it in x minus 2y. So x is 2, and y is -1. -2 multiplied by -1 is +2, so we get 4. So when I plug in 2, -1, I end up getting x plus y equals 1, which satisfies the first equation. X minus 2y equals 4, which satisfies the second equation. So we have the correct solution for the system. Okay, so the first equation here is -y equals, I can move the 3x to the other side, it would become -3x plus 6. Multiply by minus on both sides, you would get y is equal to 3x minus 6, because negative times -3x is +3x, and +6 times -1 is -6. We have to move the -4x to the other side in the second equation. If -4x moves to the other side, it becomes +4x. And we have -8. And we need y by itself on the left-hand side, so we have to divide by 2 on both sides. 2y divided by 2 is simply y. 4x divided by 2 is 2x. -8 divided by 2 is -4. And let's use blue for line 1 and red for line 2. So we know the y-intercept for the first line is -6, so it is right over here. And that is an increasing line. And the slope is 3. So if I plug in 2, I'd have to get 0. So that is the first line. The second line is 2x minus 4. It is also an increasing line, but the y-intercept is at -4. And again, if I plug in 2, I would get 0. So the point of intersection is right there. So 2, 0, and that would be the solution to this equation, system of linear equations. It is always recommended to check so that we don't make mistakes. So when x is 2 and y is 0, the first equation must check out. So 3x minus y would equal 3 times 2 minus 0, which is 6 minus 0, I get 6. So 3x minus y equals 6. So the first equation checks out. Now, when x is 2 and y is 0, which is our point of intersection, when we plug it in the second equation, we need to get negative 8 on the right-hand side. So negative 4x is 2, plus 2y is 0. We have negative 8 plus 0, which is negative 8. So the second equation also checks out. So we have the correct point of intersection. In other words, we have the correct solution. So graphing is great and all, but we don't want to graph each and every time in order to find a solution to a system of linear equations. So there is a method called elimination and there is a method called substitution. Substitution typically works well when you can take something easy for either x or y, plug it in the other equation and get an answer or solve for x. What do I mean by that? So in the first system, we have x plus y equals 10 and y is equal to 4x. And they have given us this relationship that y is equal to 4x. So what I'm going to do is substitute y equals 4x, which is the second equation, in x plus y equals 10, which would mean x plus 4x is equal to 10. 5x would equal to 10. We divide by 5 on both sides. 10 over 5 is 2. So by substituting y equals 4x, in other words, the second equation in the first, we end up solving for x, and x happens to be 2. Now that we know x is 2, we plug in that value of x in the equation that we use to get the solution for y. So y in this case would simply be 4x, therefore 4 times 2, which is 8. So the solution to the system, always x goes first, so 2, 8, and it is the same as the point of intersection of the two lines. So anytime we have substitution, we have to pick and choose our battles. We'd like to want to have an easier substitution. So the second equation to me looks a bit more challenging because there is a 2 here, there is a 3 there. But the first equation seems simpler because we have y by itself. So what I'm going to do is I'm going to rewrite the first equation as negative y equals 9 minus 4x. And if I multiply by -1, I have y equals negative 9 plus 4x. So y would be equal to 4x minus 9. So that would be my substitution. So I chose to substitute y in terms of x because I realized that, well, that is going to be the easier approach. If you think substituting for x is going to be easier, substitute for x. It is a matter of choice and it is about convenience and efficiency. So it's going to vary from person to person. So here, it sort of is obvious to me for the reasons that I've already mentioned that using a y substitution would be easier. So I have y is equal to 4x minus 9. So plug in y equals 4x minus 9 and 2x plus 3y equals negative 27, and we solve for x. So 2x plus 3 times 4x minus 9. I'm replacing or substituting y as 4x minus 9. That would equal to negative 27. 2x plus 12x minus 27 would equal to minus 27. 2x plus 12x is 14x. Minus 27 would equal to minus 27. Move negative 27 to the other side. 14x would be equal to minus 27 plus 27. Those two would get cancelled. 14x would be equal to 0, which would imply x is 0 over 14, therefore 0. Now that we've found x is equal to 0, we can take that value, plug it in our substitution, and find the value for y. So we know y is 4x minus 9. So 4 times 0 minus 9. 4 times 0 is 0. 0 minus 9 is minus 9. So we simply end up having minus 9. So the solution is the same as point of intersection. Is 0, minus 9. So we have 3x minus y equals 6, and negative 4x plus 2y equals negative 8. And I look at the two equations, and to my eyes, the first equation seems easier. So there's a negative 4, a 2, a negative 8, too much negativity. So I'm just going to go with the first equation because I have y by itself. So I'm going to rewrite the first equation. Minus y would equal to 6 minus 3x. Multiplied by -1 on both sides, we have y equals 3x minus 6. And that would be our substitution. So we take y equals 3x minus 6 and plug it in the second equation. So what we have is minus 4x plus 2 times 3x minus 6, because I'm substituting 3x minus 6 for y equals negative 8. So we will have negative 4x plus 6x minus 8 equals minus 8. Negative 4x plus 6x is 2x. And we can move the 8 to the other side. We have negative 8 plus 8. So 2x would equal to 0. Divide by 2 on both sides. X is 0 over 2, which is simply 0. Now that we've found x is equal to 0, we can take that and plug it in any one of the two equations, but well, typically the second equation should do. So we have minus, let me write that. I made a mistake here. Something wasn't right. Okay, so that is minus 12. 2 times negative 6 is negative 12. And when it goes to the other side, it becomes positive 12. And 2x would equal to 4, and x should equal to 2. So again, you can plug it in either of the two equations, but I'm plugging it in the second one this time. So plug in x is equal to 2 in that equation. So 4 times 2 plus 2 times y equals negative 8. Negative 8 plus 2y equals negative 8. 2y would equal to negative 8 plus 8. So the 8 would go away. We'll get 0. 2y equals 0, which should imply y equals 0 over 2, which is 0. So the solution is 2, 0, and it is the same as the point of intersection of the two lines. So the next method is the elimination method. The previous one was the substitution method. We call it the substitution method because we substitute one variable in terms of the other variable and solve for the solution. Here, we call it the elimination method because we are trying to get rid of one of the two variables and solve for the other variable. Now, the key thing to note in elimination method is to pick the variable that is easy to deal with. So here we have a system in the first problem, which is negative 2x plus 3y equals 0, and 2x plus 6y equals 3. So I've got to do something to these two equations so that I can eliminate one of the two variables. So I always recommend that the operation that you perform is an addition. Now, some students, I've seen people do subtraction, addition, but you can pick just one of the approaches either addition or subtraction, and go with that. But if you're comfortable with manipulating numbers, you can do it any way you want. So I'm going to add the two equations because we have negative 2x and positive 2x. Those two would go away. 3y plus 6y is 9y. 0 plus 3 is 3. So as you can see, I eliminated x, which is why we call this the elimination method. So we have to eliminate only one of the two variables. So we have 9y is equal to 3. Divide by 9 on both sides, y would equal to 3 over 9, which would mean y is equal to 1 over 3. So that is the solution for y. Now that we have a solution for y, we plug in. Again, once you solve for the equation, you can use either of the two equations to solve for the other variable. You will get the same answer. So I'm going to plug in the first equation, so minus 2x plus 3y equals 0, minus 2x plus 3 times 1 over 3 equals 0. Minus 2x would be equal to minus 1. We get x to be equal to 1 over 2. So the value for x is 1/2 and y is 1/3. So our solution is simply 1/2, 1/3. X goes first, then y. So here is another system, and again, it is a matter of choice when it comes to which variable you are trying to eliminate. In this problem, it seems as though x would be the easier variable to eliminate, and I'll tell you why. Oh, it's funny. So we have 5x plus 2y equals 1. And what I'm going to do when I write the second equation, I'm going to multiply by -5 on both sides. Which would simply mean I'm distributing -5 throughout the equation. So I will have -5x. -5 times -3 is positive 15y. 7 times -5 is -34. And we add. So when I add, those two would go away. 5x minus 5x eliminates x altogether. 2y plus 15y. So 17y would be equal to -34. Y would be equal to -34 over 17. So y would simply be equal to -2. Now that we have y is equal to -2, we can plug it in one of the two equations. It is again a matter of choice. So I'm going to plug in y equals -2 and x minus 3y equals 7. So x minus 3 times -2 equals 7. X plus 6 equals 7. Because -3 times -2 is 6. Move the 6 to the other side. X would be equal to 7 minus 6, which would mean x is 1. Therefore, the solution is 1, -2. Okay, so we have 3x minus 5y equals 11 and 2x minus 6y equals 2. To reiterate, doesn't matter which variable we try to eliminate, but we always try to pick one that is easy to work with. I think eliminating x would be easier in this problem. So how can I eliminate x? When I add them together, x should just disappear. But that's just not going to happen the way it is right now. If I add the two equations together, 3x plus 2x would be 5x. So x doesn't go away. Let me write that here. So if I directly add it, I would simply get 5x minus 11y, -5y, -6y is -11y. 11 plus 2 is 13, and that doesn't help. So that's not going to work for us. So we have to do something in terms of algebra so that we can get rid of the x's. You can cancel out a number or two numbers if they are the same. So I want to turn 3x and 2x into a same expression of some sort so that I can get rid of the x term. When we try to manipulate that, we have to again make sure that we are making the simplest choice possible. So the simplest number or expression that I can come up with to get rid of the first term in both equations would be 6x. So I want to turn the 3x to 6x. So I can achieve that by multiplying by 2 on both sides. So 2 times 3x would be 6x. 2 times -5y would be -10y. 2 times 11 is 22. Now I want to multiply the second equation by some number so that I get 6x. If I multiplied the second equation by 3 on both sides, three times 2x is 6x. 3 times -6y is -18y. 3 times 2 is 6. And you have to keep in mind, we can't simply multiply by 2 on, 2 or 3 on one side and not do it on the other. Earlier, I mentioned that I always recommend folks to use just addition, but in reality, you can use addition as well as subtraction. While you're practicing, it's best if you stick to one of them. which would be addition. So if I simply wanted to add the two equations, I would have multiplied the second equation by negative 3x. What do I mean by that? I multiply the first by 2 on both sides. And I multiply by negative 3 on both sides, the second equation by negative 3. So I have negative 6x, positive 18y, because negative 6 times negative 3 is positive 18. And we have negative 6. So in this case, I will simply add the two equations, but over here, I'll have to subtract the two equations. So if I subtract 6x and 6x would go away, negative 10y minus of minus 18y. And 22 minus 6 is 16. So we'd end up having negative 10y plus 18y equals 16. 8y would be equal to 16. Y is 16 over 8. So y would be 2. Would it be wrong to stick with addition and do it the way I did right over there? Absolutely not. So in this case, if I simply add it, I would still get rid of the x's. I will have negative 10y plus 18y, which is 8y, and 11 minus 6. Oh, I made a mistake. Excuse me, that should be 22. So 22 minus 6 is 16. Y would still be 16 over 8, which is 2. And that is the same answer as what we had over there. So whether you add the two equations by manipulating the two equations or you subtract, it doesn't matter. But I recommend students who are beginning with algebra and such to simply manipulate the equations so you always add, and this way you can keep things simpler. So now that we have y is equal to 2, so again, to reiterate, you could plug in that y equals 2 and solve for x in either of the two equations. It doesn't matter that you pick the first equation always. I could have easily picked the second one. So 3x minus 5 times 2 would equal 11. 3x minus 10 would equal 11. 3x would equal to 11 plus 10. 3x is 21, which would imply x is 21 over 3. So x is equal to 7. So the solution here is 7, 2. And if you took those two values, that ordered pair, and plugged it in both equations, both of them will be satisfied.